think without further ado, Jigyasa, you want to take over?
Sure. Thank you so much, Justin, for the kind introduction. And as I also wrote in the chat, I found out via this opportunity via Twitter. And also, I found many other opportunities like these via Twitter. And I guess that was one of my primary reasons I ended up accepting the offer from Twitter when offered for a full-time job, because I truly believe in the platform and how you can make a network of people and follow people. Yeah, that being said, my name is Jigyasa Grover. I work as a machine learning engineer at Twitter, and I'm also one of the ML Google developer experts. And today we'll be talking about how we can sculpt the right kind of data for our machine learning models. The last couple of years have seen an immense growth of machine learning in multiple domains, like right from influencing our shopping lists to cars self-driving themselves around the town. Fun fact, we have now Waymo's having like self-driving taxis around here in SF, and I'm pretty excited to maybe try that out one day. So unquestionably, machine learning is the most used and the most abused subdomain of artificial intelligence presently. It is being wielded in improving the healthcare and advancing the warfare at the same time, to scrutinizing your resume, which is might be a good thing, but it also determines your creditworthiness, and that can be troublesome at points. It can create music on its own with meaningful lyrics, to synthesizing pictures and videos of non-existent people and so on. So regardless of our fascination of it at one end to the load for it, it is influencing our decision-making power heavily and is dominating our lives at every millisecond. So that being dominant leaps in this domain are leaving the scientists, investors, policymakers, business leaders, and the audience bedazzled that human-like intelligence of machines might be just around the corner. Nonetheless, progress in machine learning has been very impressive, but there's still a lot of explanation and examination which keeps the research going on in this field. So is machine learning the future? Definitely yes, but is it magic? No, because for the state-of-the-art machine learning algorithms to work their magic, it's important to focus on the three key dimensions: well-calibrated data, sophisticated algorithms, and efficient computation. So these three pillars form the foundation of the magic of the machine learning algorithm, if I may say so. And since we have progressed so much from the rule-based approaches to more data-driven approaches, it goes without saying that machine learning algorithms are trained to capture implicit information from the data that we provide. It is true that the modern approaches are very, very data hungry. And how, in modern approaches, let's just take an example of a deep learning algorithm. So without going into much details, we know that these neural networks have so many parameters that need to be tuned in order to come up with a more generalizable model. And in order to tune these parameters, having a lot of data for them to iterate over is the key to coming up with good training sets for these kind of approaches. So we can say that quantity of data is definitely helpful. And when you think about quantity of data, that comes in the data collection part. So worthy data collection forms the foundation of the pyramid of AI hierarchy of needs. I'm not sure how many of you are aware, but there's a Maslow's hierarchy of human needs, which talk about what all needs are required by humans. So this is something that is drawn parallel to it. And the credit goes to Monica Rogati, who is a renowned data scientist and an AI advisor. So if you see, you start with data collection part, from logging, sensors, external data, user-generated content, whatever, it from social media, any other web source. And then once you've identified the source for data collection, you move to data storage, create you move the data and store it. So basically data flow, infrastructure, pipelines, ETL, and so on. And once you've moved the data to a better place or location, you clean it, you do you remove the anomalies, and you prepare it. That comes the exploration and transformation part. So basically, the the point here to be made is that data literacy, data collection, and data flow, all these form basic needs, which must be satisfied in order to achieve self-actualization or nirvana, which in our case would be the attainment of AI. So this is something, this pyramid is something that I usually find very fascinating and very interesting as well. It also puts forward the point that the type of data that you feed into an algorithm has a profound effect on the success of an algorithm. So you might have like a lot of data, but if all that data is not wordy enough, not like transformed enough, you might not even get good results. So it just works on the principle of garbage in, garbage out kind of thing. And while at one point, we definitely say that quantity of data is useful, because as Peter Norvig says, more data beats clever algorithms. But having a more better data, quality of data would definitely beat quantity of data. So machine learning models can be said to be as good or as bad as the data that you have. So coming about, so now that we've discussed like the quality and the quantity of data, let's just talk about like how you curate data. And for that, talking about academia. So in academia, there are like core machine learning and data science research groups, and they're mostly oriented more towards novelty and advancing the field. And many a times in this pursuit, they weigh this novelty of advancing the techniques or like solving new problems more than the money-making logic or even performance scaling. And in this attempt to work on the new problems, finding collaborators from pertinent domains and seeking funding from research projects are not the only obstacles they face. They also have to look for relevant data sources in the absence of in-house data, contrary to corporate giants like Facebook, Google, etc., who have access to so much of user-generated content. So these established organizations, on the other hand, they seldom have obstacles in obtaining, computation power in terms of GPUs, hiring folks with expertise in corresponding domains, or accessing relevant data. The challenge for them, however, comes up in scaling their solutions to massive user base. Any organization like this, they would have a lot of structured data available. They have it in form of raw logs, or like sensor data or user-generated content. However, they need help with developing an efficient data processing pipeline, which still remains a task. And for creating such resilient pipelines, apart from the relevant technical knowledge, they also require the skills to identify what the key signals would be from that sea of unstructured data that you have, and curate meaningful and unbiased data sets from that sea of unstructured data. So in that case, before we talk about the different approaches of building good quality data sets, we can talk about it in, let me introduce you to, let's say, 3 different data sets, which my co-author developed them, and they're also available on Kaggle if any of you are interested in trying them out. The first is the clothing fit data set. So this data set contains basically fit feedback from customers based on the products they purchased online, and other information like ratings, reviews, category information, customer measurements, etc. So basically, it reports back like if a customer purchased a specific size, they report the feedback like did it fit them or not. So this is what the data set kind of like provides. And this data set was collected specifically to tackle product size recommendation problem. The other data set that we might consider for an example later on is the sarcasm detection data set. Past studies for sarcasm detection, they have mostly used data from Twitter, but they tend to be noisy in terms of like label assignments and the type of language used, because mostly we'd use like hashtag-based supervision to identify sarcastic tweets from like, the sea of tweets that we have out there. To overcome these limitations, we instead used 2 websites. One is The Onion, which contains the sarcastic articles on the current events, and the other would be Huffington Post, which reports the real actual news. And the third data set that we also extracted from the Huffington Post, which is the news category data set, it contains about 200,000 news headlines along with their category they belong to. This data set wasn't created with any purpose in mind, but it can be put to multiple uses, which we'll talk later. These data sets are doing very well on Kaggle, and we took different approaches in creating these data sets, and that's exactly what we're going to talk about today. So circling back to the approaches to building good quality data sets. So most of the times we have a specific problem in mind that we want to address with the help of data and machine learning models. So in that case, we can consider that we have a North Star, and that's where we follow the guided search approach. And the other is we want to collect data and run multiple models on it, or just find interesting patterns and insights from the data. Like mostly it depends on like recent trends or like the COVID data that is collected. So both these approaches have their challenges, and let's just discuss how to like overcome them. So before we dive into like guided search and unguided search approaches, any questions the audience might have, and I'd be happy to answer them.
I got a quick question. That quote of more data beats better algorithms, is that what it was?
Yes, it says, yeah, more data beats clever algorithms.
Clever algorithms, but better data beats more data. Yeah, I think that was where my mind was. I think I missed the second part of it, because what about when you have biased data, right? How would that, I mean, in that case, you would think probably less data would be better.
But actually, unbiased data is what they're referring to as better data. So removing the bias comes in the better data category.
Sure. Understood. Yeah. No, I get it. I was getting hung up on the first part. I guess my mind went right to biased data, being like, maybe that's not. Then you also talked about good data pipelines. I mean, what are some, maybe you'll get into it later, but I'm just kind of curious, what are some best practices in particular when you want to create a good data pipeline?
Sure. So usually, like from my experience, what I've seen is something that is constantly monitored, first of all, and is robust enough. And that usually comes with iterations, multiple iterations of like data pipeline. But again, having specific alerts on what kind of essential data signals that we need for a specific problem are much more important than the metadata, the side information that you might need for like particular. And then there are a lot of things that, historic data, volume of data that, kind of like form the key points, but definitely we can discuss more about this later.
Sure. Okay, understood. Thanks.
So for the guided search approach, as we talked about, you mostly have like a specific problem in mind, and exactly for that particular reason, you're planning to like extract data from multiple web sources. The biggest challenge of the guided search approach is understanding the problem statement in and out. It is mostly a daunting task because you have to, based on the problem statement, you find the essential data signals that you might need. So for example, taking the clothing fit or the size recommendation problem that we had, we defined the problem as given a user and a product with different sizes, you have to recommend a product size that would fit the given user well. So this is in short, the formal problem definition that you would have, and you're planning to solve it using machine learning, let's say. And based on this formal definition, you can identify some essential data signals, which can help us identifying the appropriate data source that we need. So in our case, what would be the, let's say, four key data signals? One would be the user ID. The other would be product ID to uniquely identify the user and the product. The third would be the size purchased by the customer. And the fourth would be what was the feedback, the fit feedback. Did it fit, did it not fit, and so on. The ID features, as I talked about, they form a vital function of tying the required information and making that particular transaction or that particular data point unique. Undoubtedly, we can collect more other data signals from the transaction like product category, user age. However, they might not be of absolute necessity. They might be absent in many cases, and still you can extrapolate those. However, the ones that are absolutely needed are called the essential data signal. And it's very important to identify them while you're doing the formal problem definition, because it helps you like focus on and zero on the kind of like web source you might need or like the data set that you might need. Another consideration while selecting the data source is the source should contain enough historical data to construct sufficiently large data set. During initially we talked about how the quantity of data set is definitely important, the volume, because the more number of parameters it has, it requires more data to come up with generalizable model. So a non-supportive instances of it here, it could be when an online retailer is very new to the space and they don't have enough customer reviews reporting the fit feedback, or a news source that does not have an archive of old posts. So the corresponding machine learning models might not be might not learn suitable model parameters to capture the patterns in such an underpowered data set. In that cases, it would be wise to combine data from multiple small sources, or just find another single source to provide the large enough data set. So data volume is another important thing that must be kept in mind while you're creating your own data set. Now we can come to like unguided search. So for example, if you don't have like a particular problem to solve in mind, you're just planning to fashion a unique and worthwhile data set. And there's so many people out there who contribute to these vast repositories of data sets that we have out there. So we can refer to the news category data set further explain the challenges, because when we collected that data set, we didn't have a specific problem in mind. And it's an excellent example of this approach, because there's so many things that are tied eventually to the model that you'll be further using. So the biggest challenge, as we talked about the unguided search, is the uncertainty of not knowing what problem you're actually planning to solve. And since we don't have like a formal problem in mind, we also don't know what essential data signals that we might need. In that case, it is mostly up to you on to like what data signals do you think might be unique enough. And it makes things easier in a sense as well, because you don't need to find like a proper structure to the data signals or the number of data signals that you want in your data set. And one of the signs of a competent data set, or you want a data set to be like, successful enough or to be used by multiple people for like different kind of problem solving, is that one, it can solve practical problems. It might have some like an interesting data signal that is worth estimating, like the label or something, or like find interesting patterns into some phenomenon. So for example, the news category data set that I was talking about, which contains the articles and their tags. So one basic example that comes to our mind, like which can help solve this problem, is tagging untagged news articles online. So when you've trained a classifier which can classify like, oh, this is like a political news or this is a sports news or something, you can definitely, this is a very basic example. But one thing that you can also use is identifying any prose's writing style. For example, you can learn how much percentage of political is like, does it have humorous tone, or is it based on the latest fashion trends and all. Basically, to understand how writing styles differ for different news types, or even how, if you have the author information, you can identify how different authors have a different writing style. So based on these kind of like the same data set, you can have multiple uses, because when this data set was created, it wasn't created with a particular problem in mind. So these are different, like the slight differences that come in like guided and unguided approaches. So once you've identified, this data signal might be worth estimating, or you have like a particular data set now that you have kind of like zeroed down to like what you might have, it is also necessary to ensure that the web source that you are aiming at provides enough site information for the prediction task, because it might help to have like side information, because for example, when you were doing the size recommendation problem, the product's price from might not be the essential data signal, but it is enough to have like side information. For example, if a product is too expensive, or what kind of fabric the product is made of, is it stretchy enough or not? It definitely gives more information to your problem. However, it might not be of absolute necessity. So this metadata, or like, let's say, features like brand or fabric, etc., they provide side information, as we call it usually in these things. So definitely that is something that should be kept in mind as well. These things usually come with domain knowledge, depending on like what kind of domain you're working with, and also like intuition and like trials and errors. One important aspect that we also talked about in guided search, which also is important here, is the data volume requirement. although here we have a relaxed constraint, as I said, we do not have a specific problem that binds us. However, based on the data availability, we can modify potential problem statements that we have. For example, when we had the news category data set, we had many categories with less than 100 headlines. Since those 100 would be considered kind of like outliers in, let's say, 200 plus K headlines, or they would mostly be outliers and anomalies, we can, kind of like remove them from our records. This way, the learning algorithm can learn, better parameters, because it kind of leads to a more balanced data set instead of an like imbalanced one. So data imbalanced or balance is something that should be kept in mind as well. And another interesting point that Justin also brought up was the bias in the data. And data bias in itself is such a huge topic that it's so difficult to identify, especially when you are creating a particular data set. So it mostly trims down to the data analysis that you do, and when you finally apply a machine learning problem to. So you have to basically take care, like you're not like there are a lot of like techniques that I guess like beyond the scope of this time, but that is again definitely one should keep in mind. And then lastly, before when you're trying to create your own data set or like give back to the community or the repository of data sets, it's also necessary that we should check that if data sets already exist or not, like your data should be unique enough, because let's be real, everyone's time and effort and they're very important and valuable. So we want to ensure that we're contributing something novel back to the community, especially if you're doing this for the community work. And with that, we can think of like just extracting data is not enough. Like once you've extracted data, we have to work on the extracted data to eliminate the impurities that might have crept in before feeding it to a machine learning model. And it can be thought of just like as grooming the data set. And I'll just quickly go over like what grooming steps you could go to.
Sure.
So the first would be,
Jigyasa, I just had one comment, I guess. If we go back one more slide, I was wondering what your thoughts were around some metadata association, or actually having data. I guess, let me say where my head's kind of going. Is it fair to say that you should maybe only have the data that you are really concerned about? I guess I've seen cases where you have lots of features, and then a machine learning algorithm can hone in on features that aren't even really what you care about, and they can start making predictions based on things that are really outside of the scope of really what you're trying to solve. Does that make sense? Is that fair to say?
Absolutely. It calls to like a feature burst that we usually have. And sometimes they are like linear and they lead to like a lot of longer training periods, because it's so hard to to converge to a singular point. And that's exactly what the point is. Like should have enough essential data signals and a few of side information, and not like a whole bunch of features. Definitely.
Sure. Yeah. So people should be, just because you have a whole bunch of features, it can actually be harmful. It actually ends up causing the algorithm to go down the wrong path.
Yeah, absolutely. I believe this term is called like feature explosion, and something that we've also discussed in our book as well. Yeah.
Yeah. So only have the features that you need and nothing more, really, ideally.
Yeah.
Okay.
Yeah, and that is exactly how you can like. So when you have like a machine learning model, you can always run like feature importance tools and like rank the features in like terms of their importance, and also run like feature linearity. So like which two feature might be linear to each other. So you can even like pick and choose one of them. And when you're doing feature importance, try, if let's say if you have 100 features and you rank them, try first using first 50 features. And most of the times the model performance that you get with 100 features, you might even be able to achieve with those 50 features, because the rest features might not be even that important to that model, and instead be leading to more training time.
That makes sense. Sure. Yeah. So start small and then add as needed.
Yeah, definitely. So the first step you could try with while you're doing your data preparation is trim down the data, because there would be many cases when you're doing the initial data set that you've created. There would be like the essential data signals are missing. Let's say for the size recommendation problem and the clothing fit data set, there might be cases like, let's say the fit feedback is missing, or like the size purchased. And since that is one of the essential data signals, it is easier to just remove these transactions from our data, or find a way to produce those essential data signals. And how you do that is usually feature imputation. You would apply different techniques to impute those missing features. And this process of this excluding specific values due to redundancy, irrelevance, or just extremities is known as data trimming, and feature clipping is also one of the examples of data trimming. When you trim the data, in an ideal scenario, what you would assume is when we build a data set, let's say, you would be only using one particular source. However, there are circumstances where you need to combine and integrate data from multiple sources. For example, this process is usually known as data integration, but let's just take the example of the sarcasm detection data set that I was talking about. So on one hand, we had the non-sarcastic examples from the Huffington Post, which were like the real news. And on the other hand, I had sarcastic examples from The Onion. Though the attributes of them would be the same, they both would have headlines, they both would have like author and the content, etc. However, when you integrate them, you need to, because for a model to learn like what a sarcastic text looks like, you need to give it examples of both non-sarcastic and sarcastic. In that case, you fuse the records together in more like a vertical way, because you're using the same attributes on the top and you're just like integrating the data. That is called mostly like vertical integration. However, let's say if you are building like a data set for the cities and their information, there could be cases like fields like state, country, area, population come from one source, and the civic administration, religion, languages, festivals, etc. come from the other source. In that case, we are just like combining those two data sets on the city ID, and that is more of like a horizontal integration of the data. And most of the times, you don't find the same kind of like attributes or the information holds some exhaustive from one source, and data integration is done at different stages of a data pipeline, and it's very important to be done to have like a more exhaustive and have like all kinds of data signals involved in your data set. So keep in mind like what kind of data integration you're going for, keep vertical, horizontal, and so on. And once you have this wholesome data set, there is so much content that it is kind of like impossible to check the correctness of all. There could be like so many inconsistencies that you have to kind of filter out. Therefore, data transformation is the primary focus of it, is to like scrub the raw values, remove redundancies, correct the language and the logical semantics. A simple example could be the date format. There are so many date formats being used. Some people use month before, date before, year before. So you just have to like create like a method in which you can transform that into like one single format, the state format, city format, etc. So also like when you're dealing with textual data, how to handle special characters, removing like the grammar stuff like lemmatization and stemming of the data, just that also comes under data transformation, spell checks, and simple things like encoding the sizes in numerical order or something, because there would be cases when the sizes are reported as small, medium, large. Sometimes the sizes are reported as 0, 1, 2, or something. So you definitely have to take care of like the format of the data, and data transformation comes as one step. And once you've done this, then depending on the machine learning model that you're using, you do a lot of like feature engineering stuff. So the bottom line of all this that I wanted to talk about mostly was, usually in a machine learning pipeline or a workflow, we talk about defining a problem statement, and from defining a problem statement, people usually jump directly to defining appropriate metrics to define the success of the problem, and then choosing the right kind of machine learning model to address the problem, and deploying the model, productionizing it, maintaining it, and so on. However, in like the focus should also be on how you source the data, like where you source the data from, or like how are you fabricating your own data set, and then processing the data set and performing feature engineering on top of it. It's not necessarily, as I said, like the quantity of data matters. It's like the quality of data, how well you engineer the features, because feature engineering in itself is like applied machine learning. And so that is where the focus should be. Even Andrew Ng, who is one of the leading ML experts today, he tweeted 3 or 4 months after we launched our book about how we should move away from more code-centric AI to data-centric AI. Like for example, AI is code plus data. And so far, we've always focused on how we can have more sophisticated algorithms, or how we can have like more GPUs, more parameters, more layers in the neural network. The time has come now that because there are like so variety of machine learning models available right now, the focus should be how we can improve the data that we have because the kind of data that you feed into a model has a profound effect. Like even if you have the same kind of model, but you provided two different data sets, you'll see the impact it has on the performance of the model. So it's definitely the time to move to a more data-centric approach to machine learning and AI. And with that, I would like to tell you all that we have published a book called Sculpting Data for Machine Learning on the similar lines. It is the first act of machine learning because it tells you how data forms like a strong foundation of any machine learning model, starting from right from scraping the data. If you are like someone who's in academia, and it has like it talks about end-to-end process. It's definitely if you're adapting Python, definitely check it out. We use all open source tools like Python, Selenium, BeautifulSoup to help, and it gives you a big repository and access to a repository of how to basically fetch real data sets, and along with step-by-step of data preprocessing and feature engineering, like I talked about feature flipping and so on. So all these terms, feature explosion, are all explained in the book well. And it also gives an introduction to machine learning paradigms from a more data perspective rather than just learning the theories of a mathematical formulas about it. Glad to have it endorsed by leading ML experts. I'm sure you've heard the name of Lawrence Murney, who is the lead AI advocate at Google, Mengting Wang, and Julian Macaulay, who is the professor at UC San Diego. And with that, thank you so much for coming to the talk, and happy to take questions. Sorry.
Excellent. Awesome, Jigyasa. That was really, really nice. Thank you so much. Yeah, there aren't any questions that were posted along the way, but if anybody would like to unmute, ask a question at all, right now would be a good time.
I guess not.
Hey.
Was that somebody who came off mute? Otherwise, I had a comment. I had a feeling of almost deja vu with this speech. I'm so intrigued by the idea that machine learning and AI has come full circle back to what I kind of callously term the data janitor work. Do you think that's been a natural progression or something that people have had to learn the hard way?
I think probably I would say it's learning the hard way, because people were so focused on, like the novelty of, architectures and having more powerful machines, that in this journey, they kind of like forgot about how you can like put more emphasis on the data, as well as I talked about like having three pillars, like sophisticated algorithms, well-calibrated data, and then efficient computation. People usually gave those two credits and forgot about the data during this journey. And while we've come to a point that we have like most of the sophisticated architecture and machines, it's time to like, push the data as well and basically squeeze the best out of it. I believe Eric was saying something. Thanks, Sridhar. So I see Sridhar has a question about how does data curation works in terms of unsupervised learning.
Yes.
And to actually answer your question, unsupervised learning is exactly what you talk about unguided search, because when you do unsupervised learning, you don't have a particular label in mind, or like when you're just trying to find interesting patterns out of it. And that's exactly where the unguided approach comes. Like you don't have a specific label in mind. You, as we said, like you just can have different data signals and then run your algorithm on it to find interesting patterns and trends.
Yeah, I guess to elaborate a little bit more on that, maybe like how does the curation piece come into it then? Or do you have to try any different technique if you're using unsupervised versus supervised?
So again, when you curate a data, as I said, it can have multiple use cases, and it just depends on like you can use the data for anything. You don't usually create it like, at least in the unguided approach, you do not create it with the particular aim of like solving a problem, or you'd be applying unsupervised learning to it or supervised learning to it. So basically having any essential data signals that you believe, for example, when I believe recently when COVID data was collected, people didn't have any, though there was definitely a signal that having COVID or not having the probability of not having COVID, but then there were other signals like your geolocation, etc. And then you run like unsupervised learning, and for example, the nearest neighbor problem or something, you can find clusters of similar pieces, and that's exactly where it comes to point. There is no data set that caters to unsupervised learning or supervised learning.
I see. Okay, sure. Yeah, I mean, what are some of the challenges that you see? I just, you don't need to get into specifics, I guess, but I mean, Twitter must have so much data. And so what are some challenges maybe that you see with regards to once you have that type of volume of data, what are some techniques, I guess, that you're trying to use, or things that you've had to like run into when you've dealt with large data sets, just in general, I guess?
Absolutely. So as this is also comes back to something that we just discussed, that when we have lots of data, it's kind of like easier to form features out of them. But when you have like 100 and like 500 kind of features, and you try to use it in a model, of course your model performs well. However, it comes to performance scaling. You cannot use that big model to serve like say 100,000 people who are like in a small fraction of millisecond at a time, because latency is something that you have to consider as well. You do not have like access to we do have access to infrastructures, we do have our own data centers, but again, there's a limitation, like a physical limitation on what comes to wide serving. So that is exactly what we are trying to work on, like optimizing the model, trying to cut down the features that we have and only keep the ones that are like absolutely important. Then you also have to like create embeddings out of, the textual features, like tons of textual features that you have, or like the user features that you have. You cannot use like just one, have each feature as a category or something that would just like blow up our feature space. So that is definitely one of our biggest concerns right now.
Gotcha. Sure. Is it harder to do like natural language processing? I know there's like, LSTM approaches where you need to essentially, understand the context and the word and kind of like, take a look at chunks of data, I mean, are those harder problems to solve for a machine learning algorithm, do you think, or is it just sort of across the board, I guess, difficult challenges with regards to building models?
I guess definitely when natural language processing comes, it's like harder than what you would use as normal binary or categorical features. And this is also demonstrated in the sarcasm detection data set that we talked about, because sarcasm is something that comes in context. You cannot just read a word and say, oh, that's a sarcastic word. You have to understand in which context it was said. For example, a simple thing like to wash off COVID-19 vaccines use borax mats, like people had said stuff like that. So like if you look at each individual word, there's nothing sarcastic about that. But however, when you like see it in a context form, it definitely becomes more sarcastic. And that's exactly why it's like a much harder problem than using normal binary or like categorical features. I see Jason also has a question about using auto ML tools to sample different. Definitely, these auto ML techniques come in handy. And one also, we also talked about having feature tools to automatically generate features, like given a data set, just like generate n number of types of like features that you have. Again, the problem comes to the fact that it just blows up feature space. So those kind of like feature tools are very important to get started. Like they're very helpful. For example, give a data set, find let's say 200 features, different combinations, and you have those 200 features. Instead of like directly feeding to the machine learning model, what I would suggest is having a feature importance pipeline, rank those 200 features, and then like find the linearity between them, and then only choose the ones that are important and like not linear to each other. In that case, you have had the help of these feature tools to generate features for you. You don't have to like do a lot of manual work in that. However, you also do not like directly use them. You'd like filter them out. So that is some interesting stuff that you can keep in mind. Yeah, you're welcome.
Yeah. Another question here.
I'm not sure I understand your question, Sridhar. Is it possible for you to like rephrase something?
So I I've been just listening to a lot of machine learning, so I'm just getting speed on that. But you have the concept of transfer learning, where you already have these models, and then you might have limited data, and then you use that, like in, I don't know, maybe deep learning or other things, and then you have your data to go and then try to do interpretations of it. So in that sense, like if would sculpting or whether curating your data and using your transfer learning or something, does it have any impact, or do we need to do that or not?
Okay, yeah, I get your point. And in that case, I'd say like data always forms the foundation, like regardless of the type of learning algorithm or like the kind of like transfer learning or whatever you're trying to do. Definitely having the data aligned to what your previously trained model was would definitely come in handy. But again, I might not be able to comment a lot on it because since I'm not sure like the exact use case you're talking about, and most of the things in machine learning and data are kind of like tied to the use case. So yeah, I hope it answers your question.
How often do you end up changing your original use case as you go through the process of cleaning and sculpting the data?
I guess mostly not a lot. Not a lot of pivoting is done, especially when creating the data and while processing the data. However, when it comes to like feature engineering, like when you come to that stage, definitely a lot of back and forth is done because it depends, again, as I said, you don't want to blow up the feature space, you have to see the linearity and again, like optimizing the model. So that's exactly where like a lot of back and forth come. But when you're like extracting the data and like, creating like a data processing pipeline, not a lot.
So how does the AI fairness or AI bias work when you try to clean the data? Do you check it to see if the data inherently had some bias, or do you have to incorporate that after you clean the data, or how do you take care of that?
Sure. So the bias in dataset can come in like various forms. One is definitely imbalance in your dataset also can lead to bias. For example, like certain section, like let's say you have like a city or like a set of people and you're trying to do like exploratory data analysis on it, and you kind of find like certain section of people are like when you kind of like plot the graphs and so on, you'll find out that a certain section of people are, at least in your data set or the kind of mechanism that you have for collecting the data set, they are related to a certain kind of, let's say, problems or like credit worthiness or like crime or something. So that is something, again, as I said, use case, but you can definitely plot out your graphs. But again, the other set comes when you're training the machine learning model, like what kind of weights are being assigned. So there are like two different aspects that come into play at two different stages.
Okay, thank you.
You're welcome. Yeah, I guess those were most of the questions in the chat, Justin.
Yep, I think we've covered most of everything that was here. I encourage everyone to go out on Amazon here and pick up the book. I know this was probably took a fair amount of time. I have a lot of respect for authors. I've tried to write blogs and stuff like that, but to sort of coalesce it into an entire book, I have a lot of respect for you, Jigyasa, for doing this work and putting it together. So I know it. I know it's hard. Are you working on a second one, I guess?
Not so far. I have to figure out few logistics, and I'm trying to like before. I'm trying to gain more experience before jumping into this world, because definitely this took a lot of time because we have a lot of like code examples as well. So writing those code stuff and then the basically normal stuff you write in a book definitely is time consuming, but glad it worked out, and hopefully we can have something new soon.
Yeah, for sure. Well, great. I appreciate you coming to the group tonight, presenting, reaching out to me. We will also be having you and I did an interview on the podcast, and so that should be coming out here in probably the next month or so. So people make sure I dropped a link off to podcast.appliedai.mn. People can subscribe to the podcast, and but yeah, we'll be having our conversation out in there probably sometime next month. So that'll be fun for us to publish that as well. And you're always welcome to come back anytime. Sign up for the meetup and if you're ever in Minnesota, stop on by for sure.
Yeah, for sure.
without-
Thank you so much for having me here.
Yeah, for sure. So yeah, so just a reminder to everyone here, we will be meeting in May, a system for interactive data-driven decision-making, and that will be the first Thursday of the month, May 5th. Is that date. So thanks again, everyone, for being here tonight. Thanks again, Jigyasa, and have a good evening.
Bye-bye. Have a good evening.